All right, so this is the review session for differential equation final exam. Diffuse differential equations. Okay, so you know that the material for the exam is um, chapter 4 and chapter 7, 4.3, 4, 6, 7, 4 sections from here and 3 sections from 7th chapter. So you can expect a question. So in chapter 4, I think it's better if I write it like this. Chapter 7, 7.1, 2, 3. So we have this thing. So I removed 4.1. 4.3 is needed for all these, for 4.4 and 6. Okay, so even if you do not get a question from there, you should know how to do 4.3, because it will give you the half the solution in 4.4 and 4.6. So there are two methods. In 4.4 you have a method of undetermined coefficients, UC, undetermined coefficients. In short, we can also call it UC. And in 4.6 you have variation of parameters method. So I will ask one questions from both. Okay, so basically in 4.4 these both methods are for finding YP. These both methods are to find YP, because you know that in non-homogeneous equations, when you have non-homogeneous equations in 4.4 and 4.6, your solution is YC plus YP. So YP will come from one of these methods and YC comes from 4.3. Okay, YC comes from 4.3, which is the homogeneous part. So that's why 4.3 is important. So I may give you a question from 4.3 and then I make it non-homogeneous and ask you to use this method to find YP. Or I can just give you a question from non-homogeneous part and you can find YC and YP both. Okay, so you can expect one question each from these two, 4.4 and 4.6. So total two questions. So and then one question from 4.7. So in 4.7 this is 4.4, this is 4.6. Okay, and in 4.7 you have Cauchy-Euler equation, and the method is little different for Cauchy-Euler equation. For Cauchy-Euler equation you have one question from there. Okay, so again I know we know there is a different method for that. I can review that for you, and then two questions from here. Okay, so you will have total 5 questions in your exam. Total 2 from 4.4, 4.6, 2 from question chapter 7, and 1 from question for section 4.7. So this is the breakout for. So if you have any questions, you can ask me that first. Otherwise, I can just review all these topics one by one. Yes, yes, I'm recording. So you want to leave? Go home. Oh, yeah, okay, I know that. Okay, okay, go. I'm not asking you anything. Anyone who wants to leave can leave without telling me. Um, so any question, guys? Any questions? Yes. Okay. Okay. Let me open the book. Question number 23 in exercise 4.7. Evokes. So basically here question 23 from Cauchy-Euler equation. So if I 4.7, here are the exercises of 4.7. Question number 23 is um, x square y double prime plus xy prime minus y is equal to log of x. Okay, so why this is Cauchy-Euler equation? Because the derivative and the power are the same. Why he does not allow me to click anywhere? So you see here, this derivative and the power, they are same. Derivative and the power are same, right? So no derivative here, no power of x. Okay, so this is the Cauchy-Euler equation basically. You have the same derivative, same power. Anyway, so what we do, we write first of all its auxiliary equation. Okay, so its auxiliary equation is, for the whole x square y double prime, we write m into m minus 1. So remember, for uh, for y, no m, okay, no power of m. For x, y prime, both, I will write m, okay. For x square y double prime, both go away together, okay. This is m into m minus 1. So then now plus x y prime only gives me m, and minus y will only give me 1 is equal to 0. Right side is always 0, remember, right? Right hand side of auxiliary equation is always 0. I wrote it many times, is always 0. Why I emphasize? Because students still, write the log of x on the right hand side. Now if you multiply this m inside, I will get m square minus m plus m minus 1 equal to 0. So m and m cancel, so you got m square equal to 1. If I send 1 on the other side, so m square equal to 1. So from here you will get plus n minus 1. So these are the roots of the equation, distinct real roots. So therefore, the first solution, you see, if the equation is homogeneous, if there is no log, if it is just 0 on the right hand side, then this is my final solution. C1 x to the power 1 plus C2 x to the power minus 1, because there are two roots, m is equal to 1 and m is equal to minus 1 if you write separately, okay. So this is the solution. But because it is not a homogeneous equation, there is a function on the right hand side, so this is half the solution. This is only the complementary function yc, okay. This is something which you do for homogeneous equation. If it is homogeneous, right side 0, you will stop here. So this is your yc. Now for yp, we use, for Cauchy-Euler equation, we always use variation of parameters. So this will give you a practice for section 4.6 as well, okay. So variation of parameters is basically given in section 4.6. So you can use variation of parameters. So in variation of parameters, you pick what you need, y1. Y1 is this. Y1 is this. The first solution is y1, second solution is y2, okay. So you got y1, y2. Y1 is x, y2 is x minus 1, or you can write 1 over x, it's your choice. Then fx. Fx is the right hand side of the equation, but fx is the right hand side of this equation when you use variation of parameters, okay. They give you equation like this: y double prime plus some function with y plus some function with y prime equal to f of x. This is your function. This is your right hand side. Okay, this is what we use here. So here you see there is an x square y double prime. So I don't want x square. I want 1 here. You see there is nothing here. No x square. It's free. So my fx will be log of x divided by x square. This is my fx. If you have something here, okay, divide that on the other side. That will be your f of x. Always remember. This is another mistake which students do. They only write log of x on the right side. Log x is g of x. We are not looking at g of x. Okay, so you have to divide by x square. Got it? Okay, give me a second. I am stopping for a moment. All right, so after that I need to find w, which is y1, y2, y1 prime, y2 prime. So this is something we do in 4.6. So this gives you the revision for 4.6 as well. Okay, if any equation is given, you got yc is c1x, whatever yc you get. Of course in 4.6 you will get yc from different method, because over there you don't have x square and x in your equation. They are constant coefficients and your solution comes out to be exponential or cosine sign. Here you don't get exponential solutions. Here you get x to the power n for Cauchy-Euler equation. So if you find that now y1 is x, y2 is x minus 1, the derivative of x is 1, the derivative of x minus 1 is this. So now if you multiply diagonal and then off diagonal, what you will get, x into x minus 2, you will get x minus 1, and when you take x minus 1, so you got minus 2x minus 1. Now you will get w1. w1 is 0 fx and second column of w as it is. You can write minus y2 fx directly as well. If you want, you can write minus y2 fx directly. Minus y2 is minus x minus 1, and fx is log of x over x minus 2. So this will become minus x minus 3 log of x. If I bring this up, it will become minus 3. Now w2 is y1 prime as it is, but second column is 0 fx. And if you want to write directly y1 fx, that is also fine. You can write w2 directly as y1 fx. So y1 is x, fx is log x by x minus 2. So if you bring it up, you will get x minus 1 log of x. Okay. So these are the three things. After that, what you do, you find u1, u2. Now, your u1 prime is w1 by w. I will write these formulas, only these formulas. I will not give you formula from 4.3 or 4.4. From 4.6, I will write these variation of parameters. Okay. These formulas I will write w, w1, w2, u1, u2, and at the end yp. Okay. I will give you these formulas from chapter 4. And chapter 7, I will give you all the formulas. So don't worry about this. Formulas will be given. You should know how to implement that. So w1 is minus x minus 3 log of x divided by w. W is minus 2x minus 1. This is your w. Okay. So minus 2x minus 1. So now if you bring it up, it will become 1 by 2 x to the power minus 2 log of x. Right? If I bring x minus 1 will become plus 1. So it will become x minus 2 log of x. Now w2. So w2 is u2 is w2 by w, which is w2 is x minus 1 log of x divided by minus 2x minus 1. So x minus 1 will cancel. So you will just get minus 2 log. Now you have to integrate, right? Now we need to integrate. Either you can integrate directly here, but because I have to use integration by parts, so I cannot do it here. So I can write them separately. Integrating 1 by 2 now. If I integrate 1 by 2, it will yield u1 is equal to integral of, if I take u1, it will be integral of 1 by 2 is constant, integral of x minus 2 log of x. And for that, I need to use integration by parts. So log of x as first function, x square as second function. I take this as u and this as v. So integral of v will become x minus 1 by minus 1, and then minus derivative of u, this derivative of u 1 over x, and so here we take the derivative of this thing, but the second one remains as it is, x minus 1 by minus 1. This remains as it dx. Okay, so this is what is the integration by parts. Let me write it here. Integral of uv. If you have two functions uv, u as it is, we integrate v only, and then we take the derivative of u, which I take here. You see, log becomes 1 over x, and integral of v dx, which is same as outside thing. This is the same as this. So I wrote x minus 1 by 1, x minus 1 by 1 as it is, and then the whole thing derivative. This is integration by parts. Okay, so this is the formula I used here. So now it will become minus 1 by 2 x log of x. This is your first thing. Minus minus will become plus here, and you get x minus 2 dx. You see, we have to simplify. This x will go up and it will become x to the power minus 2. Now I will integrate this. So minus log of x by 2x, and it will become x minus 1 by 1. So I can write minus 1 by x. So I do not add a c here. Okay, don't add c. You know that when we integrate, we add c. But we will add c in the solution. That's why we do not add c here. Okay, so don't add c here. Don't add c. Okay. Similarly, if I do u2, u2 will be the integration of just log of x dx. Okay, this one is u2. So I'm integrating this 2 now. Okay, so 1 gives you this and 2 gives you this. So now log of x has no function with it, so I can use 1. So I can use u as log of x and 1 as v. So minus 1 by 2 outside, there is this minus 1 by 2 as well. I think I missed it. This 1 by 2 from outside, so this also has 1 by 2x. Now minus 1 by 2, again u as it is, integral of v minus derivative of u integral of v dx. Okay, so integral of v is 1. So you got minus x log of x by 2, and here x and x cancel, so you got just minus x, so it will be just plus x by 2. So again, do not add c here. Okay, so again we will not add c here, because we are solving a differential equation. We will add c in our solutions. So hence our yp is u1 y1 plus u2 y2. So u1 I got minus log of x by 2x minus 1 by 2x. This is my u1, and then y1 was just x, plus u2 I got minus x log of x by 2 and plus x by 2, and u2 is 1 over x. So I put the values of u1 and y1. u1 y1, u2 y2. See, I put the values from u1. u1 is this one, u2 is this one, and y1 y2 from the beginning. Okay, so this is what you got. Now if I simplify, you see x will cancel these. This x, when it multiplies inside, this x will cancel this x and this x, and this x will cancel this x and this x, because they will multiply with both of them. So I will get minus log of x by 2 minus 1 by 2, and from here I will get minus log of x by 2 and plus 1 by 2. So 1 by 2 cancels, and you got 1 by 2 1 by 2 minus log of x. So this is your yp. Alright, so hence the general solution is, now the general solution, because I have found both yc and yp, so now I can write the general solution. So which is yc was c1x plus c2x minus 1, so I can write c2 divided by x and yp is minus log of x. So this is your final solution. All right. So this gives you the practice with the um, 4.7 as well as 4.6. So 4.4 is easy, right? If you have any question from 4.4, method of undetermined coefficient is easy because the right hand side, we take the function similar to the right hand side and then uh, substitute in the equation and get the answer. Oh, so yeah, now you can do it, right? Question 4.6. This is the same as this variation of parameters. Let me check if there is any difficulty. In 4.6, what you have in 4.6? So 24, I think I did it in the class. I remember that. So is it the integration? The problem is in the integration or in the method? Because method is the same as this one. You have to pick y1, y2, and in 24, y1, y2 are given to you. In 4.6 number 24, y1 is given to you, y2 is given to you. So you just have to, I think I did this question during the lecture. And fx is the right hand side, which is secant log of x divided by x square. Because the equation again has x square y double prime. It is a Cauchy-Euler equation, so you can divide by x square to get f of x. So if I take first derivative, it will be minus sine of log of x into the derivative of log of x. Because first I will take the derivative of sine. First I will take the derivative of cosine, that becomes sine, but then we take the derivative of inside function, which is 1 over x. So similarly, y2 prime will be sine becomes cosine of log of x, and then the derivative of log of x is 1 over x, similar to this one. So these are two derivatives. Now if you find y and y prime, sorry, w1, w2, all of these things. So w1 is y1 prime, which is minus sine log of x divided by x. Sorry, not this is the derivative. So I have a cosine log of x. This is my y1, and sine log of x. This is your y2, and the derivative is minus sine log of x divided by x and cosine log of x divided by x. Now if you take the cross product, it will become cosine square log of x divided by x, and if you take this minus from the formula and minus from here, you see it will become plus sine square log of x. So if you do everything carefully, things becomes very easy. Now you see 1 over x is common, so cos square plus sine square is 1. So the answer is 1 over x. Okay. Now w1 is minus y2 f of x. You can write it directly. Minus y2. So minus sine log of x. This is my y2, right? Minus sine log of x. And fx is secant log of x divided by x square. Is it? This is w1. Okay. And now w2 is y1 f of x. It does not have minus. You see, for 1, if you want to write directly, for 1 we write 2, for 2 we write 1. But 1 has a minus sign, the second has plus. So now y1 is cosine log of x into secant log of x divided by x squared. Now if you want to simplify, you see secant is 1 over cosine. So you can write them as sine log x divided by cosine log x and into x square. X square is in the denominator. Similarly here, cosine log of x divided by x square, and this secant goes down and become cosine log of x. Okay, so here cosine and cosine cancel, so you got just 1 over x square, and here I will tell you what that is. Now u1 is, if I follow the same steps, u1 is w1 by w. w1 is minus sine log x divided by cosine log x with x square, and divided by w. W is 1 over x. Okay, so that will become x. If you divide by 1 over x, it will become x, right? So if you divide by 1 over x, it means it will multiply by x, right? So if you multiply this by x, you will get x by 1. So x and x square will cancel, so you just got 1x. So minus sine log of x over cosine log of x into 1 over x. This is what we do. Now if I integrate directly from here, if I integrate, I got u1 is equal to integral of 1 over cosine log of x into minus sine log of x over x dx. Why I wrote it like this? You see here, I wrote these together. Why? Because this is the derivative of cosine. If I take the derivative of this thing, it is this. If you take the derivative of cosine, it is minus sine log of x by x. Remember? At the beginning I did that here. What is the derivative of cosine? It is minus sine log of x 1 over x. You know that whenever there is a derivative with d of x, the answer is log. Whenever there is a function in the denominator and its derivative is given with dx. See, if there is a function in the denominator and derivative is given, it is log of f of x. This is your answer. So I can use this directly. So it is log of cosine log of x, log of this denominator. Okay, so that's why this integration is not that challenging. Now u2 is w2 by w. So w2 is, let me see what my w2 is. W2 is 1 over x square. 1 over x square. So w2 is 1 over x square and w is 1 over x. So 1x will cancel. So you just got 1 over x here. Now if you integrate this, you got u2 is equal to 1 over x dx, and the derivative of 1 over x is log of x. See, things are not difficult. Just by looking at the question, we may be frightened that, oh, this is too much, I don't know what will happen. But if you do calculations carefully, answers are coming very simple. They are not that difficult. So hence my YP is, the question was, find the general solution of the given non-homogeneous equation. So now I can write YP and YC. So therefore my YP becomes U1 Y1 plus U2 Y2. U2 Y2. So U1 came out to be natural log of cosine log of x, and Y1 was cosine log of x, and U2 is just log of x, and Y2 is sine of log of x. So this is my YP. Also what we, because he said write the general solution, so it means I have to write YC as well. YC is C1 Y1 plus C2 Y2. This is U1 Y1 U2 Y2. YC is C1 Y1 C2 Y2. So Y1 is cosine log of x, it is given to me, plus C2 sine log of x. So now if you add these two, you will get the final solution. So of course it is calculation wise, this is little maybe difficult. We just have to be careful, but it uses calculus, simple calculus, simple integrations. And because we do not practice integration, so we are always in trouble. So this is my yc, and then if we add yp, that is my yp. Plus log of x into sine log of x. Okay, so now if you want, you can combine them. You see this cos x is common, so you can combine them. Similarly, this sine x is common, you can combine them. If you want to combine, you can combine, otherwise no problem. So c1 from first blue line plus log cos log from second blue line. Okay, so if you take this common, I have cosine log of x outside, and if I take the red ones common, then red one gives me c2 plus log of x only, and it gives me with sine of log of x. So this should be the best answer, but if you stop here, it is fine, no problem. Okay guys, so this is your variation of parameters, so I hope you should not have any problems. um, if I think that some integration in the in your exam is difficult, I will write the formula for that on the board or at the end of the exam. I will see. Of course, when I make the exam, I will solve it. And if I realize that this integration may be little difficult for students, I will write the formula at the end or during the exam on the board. Okay. So, but simple integration you should know, like sine is cosine, cosine is sine, 1 over x is log of x. I will not give you these type of formulas, right? Like this formula, 1 over x, this formula you should know, okay? But this formula I can write, okay? I can give this formula that 1 over fx, f prime of x is log of x. So you can use that here. So these type of difficult formulas I will write. Simple formulas you will have to remember. Do you want to see something from 4.4 or I can go to chapter 7? I think 4.4 is easy. Is it Al Yazia? Okay, so in exercise 4.4, let me pick something. What do you want? I can do question number 12. Now? Okay. So you can join it now, right? That's fine. Anything you need, right? 12 seems little difficult, that's why I'm doing it, okay? Why double prime? Sorry? During the assignment? From the assignment? What is that? Okay, from the assignment I pick something, that's what you are saying? Okay, let me open the assignment then. Differential equations assignment 2 from 4.4. I have 2, 5, 8, 12, 30. So 12 is there in assignment, okay? So 12 is there in the assignment. So again, you see, this is a non-homogeneous equation. Right hand side is not 0, right? Is not 0, so it is non-homogeneous equation. If it is non-homogeneous equation, you should know that your general solution is yc plus yp, right? So this is for you. Just write these things that we have to find all these things. Now for yc, I have to write the general auxiliary equation only. The auxiliary equation, because these are constant coefficients, so y square becomes m, y double prime becomes m square. That's it. Okay, because when you have constant coefficients, it is not like 4.7. When the coefficients are constants, then y double prime becomes m square, y prime becomes m, okay, and y no m, okay, no m. So see, y gives me no m here, but y double prime gives me m square. Now if I take factors, these are m minus 4, m plus 4 equal to 0. So you got m is equal to plus 4 and m is equal to minus 4. These are two distinct roots. Therefore, your yc, because it's a non-homogeneous equation, this will only give you yc. C1 is c to the power e to the power 4x, because this is constant coefficients. For constant coefficients, my solutions are exponential, not the power. In Cauchy-Euler equation, if you have m, it gives you x to the power m for Cauchy-Euler. Okay, but here it is not x to the power m. Your m gives you e to the power mx for constant coefficients. In Cauchy-Euler, it gives you x to the power m. Okay. So now I will use method of undetermined coefficients. Method of undetermined coefficients says that uh, let, so let me write, we are using method of undetermined coefficients, UC. So method of undetermined coefficients says that take the yp as the right hand side. Okay, so let or assume yp similar to the right hand side, but change the constant. If the constant is 2, change your own constant and exponential will remain the same. E to the power 4x will remain the same. This e4x will remain the same. Okay, but you will introduce your own constant. This will remain the same. 2 will be replaced by your own a. Now the second thing is you compare compare your yp with yc. Compare for any matching term. You see, this matches with first term, c1 e to the power 4x. You see, it matches with this one. They are the same. c1 e4x and e a4x are the same. So I will reject it. So reject this yp. So this implies you. So if it matches with any term, you will reject it. So what will you will assume? Next, assume yp is equal to multiply with x. Introduced one x here. Okay. Now if you compare no matching terms. Now no matching terms with yc. You see, yc and yp are different. Now x e4x is different than e4x. They are not matching. Okay. So no matching terms with yc. This is very important. Students miss this one. So if there are no matching terms, accept this yp. Okay. So it means accept it. So now what I will do, once you accept it, we rejected this one. So this is not my yp now. This is my yp. Now I will replace this in my original equation. So I will take the two derivatives. Yp is a, x is 1 e4x as it is, plus e4x ax as it is, and you get 4e4x. This is your first derivative. Then the second derivative is a into 4e4x you got, plus here 4a is constant, but x and ex will again give you product rule, plus x 4e4x. Okay, so you have to use the product rule here. Now so I can simplify this. See, 4x 4e4x gives you 8ae4x, and at the end you have 16 4 the 16axe4x. So this is your second derivative. So I will replace, so therefore the given differential equation gives, now I will replace that. So what was given differential equation? Y double prime minus 16y. So what I will do, I will replace yp there. This was my equation. I replace y by yp. So what is the second derivative of yp? I just found that. I can replace this here. This is the second derivative of yp. And then minus 16 yp is ax e4x equal to 2e4x. Now these two cancel. You see, they cancel, right? So these two terms cancel, and now I got only 8ae4x is equal to 2e4x. So they will be equal if 8a is equal to 2. Otherwise, they will never be equal. So if 8a is 2, now you divide by 8, you got 1 by 4. So a is 1 by 4. If you divide by 8 on both sides, 8 is gone and 2 4s are 8. Okay. So this is 8. So therefore, my yp, which was a e to the power ax e to the power 4x, I replace the value of a in my yp. So if you go up, what was my yp here? So I replaced my a here. Okay, that's why we call it method of undetermined coefficients, that we introduce some coefficients in our yp, but at the end we find that a. Now everything is complete. Now I can write my general solution. Hence the general solution is y is equal to yc plus yp, which is yc is c1 e to the power 4x plus c2 e to the power minus 4x plus 1 over 4 x e to the power 4x. So I added these two, and that is my final solution. Is that okay? Does it help? M power 3, yes. Okay, so if there is, for Cauchy-Euler, uh, here I did Cauchy-Euler equation, right? So I wrote it here that for y, no m, for x, y. See, this whole thing becomes m. So you have to be careful here. The whole thing becomes m. So this whole thing becomes m. This whole thing becomes x. Oh, and if you have x cube y triple prime, then this whole thing will become m minus 1 and m minus 2. We add factor. M minus 1 will stay there, and this is a new factor. But if you go down and you have constant coefficients, then y3 will give you just power, third power of n. Okay, so this is the difference between Cauchy-Euler and a constant coefficient. In Cauchy-Euler, your solutions are also different. That your, for Cauchy-Euler equation, your m, the root m, gives you the solution x to the power n. Okay, if this is your root of auxiliary equation, then this is your solution, x to the power n. But here, when you go to constant coefficients, right, when this is your root, m is your root, then when m is your root, then the solution is e to the power mx. So this is the difference. Okay, so you have to be careful and remember these things. Okay. All right, so now chapter 7. In chapter 7, I will ask you, if I give you some, you know that there is a Laplace transform in chapter 7. So I can do one question. I will ask you two parts. One is, this is the Laplace transform of any function dt. Okay, so if I ask you what is the Laplace transform of ft, then you can use this one. Okay, then you will solve. And how we solve it? We replace this infinity by m, we integrate this function, get the answer in terms of m, and then we take the limit as m goes to infinity. So this is the this is your uh, definition. So let me see what assignment I gave you here. What did I give you in assignment for chapter 7? You need what you were saying. What was the question? 7.123 are there, right, in assignment? So what do you mean by that? I may ask you one differential equation will be given to you to solve, and one question will be finding the. I did not give you anything from 7.1. Where is that? Let me check the assignments. Assignment 3 is that, right? So in assignment 3, 7.1 has 1, 11, 19, 27, 31. So I can pick something. Let's say if I pick problem number 1 or 111. So see, if I give you problem number 1, then you do not have tables for that. So what you will do, let's say 7.1 number 1. They said this is your function f t is equal to minus 1 when t is between 0 and 1, and it is 1 when t is greater than 1. So see, if I find the Laplace transform of this function, I have to integrate this function with e minus st dt. Now the function is different. Excuse me. The function is different for before 1 and after 1. So what I will do, I will break my interval from 0 to 1. I will write 0 to 1 dt plus 1 to infinity. Right? We can break our interval. Why we broke it? Because between 0 and 1, my function is different. Between 0 and 1, my function is minus 1. You see, between 0 and 1, my function is minus 1. And from 1 to infinity, my function is 1. So see, when I break the interval, we have to go from 0 to infinity. But why I am taking rest at 1? Because my function is minus 1 here and my function is plus 1 here. So we integrate this first and then this separately. Now if I integrate, this is just minus 0 to 1 e minus st, and here it is because infinity is here, so I will take the limit here. I will not take the limit in the first integration because here we have infinity. Now the integration is very simple. If we integrate, it is minus st divided by minus s from 0 to 1 and plus limit m goes to infinity. If I integrate, it is e minus st by minus s from 1 to m. Now if I replace 1 in t, this is the value of t, right? We are integrating with respect to t. So these are the values of t. These are the values of t, not the values of s. So if I put t is equal to 1, it will become minus e to the power minus s divided by minus s. Give me a second. So see, students don't let me do anything. Okay, now if I put 0, it will give me minus from the formula and minus 1 over minus s, right? If I put 0. Now here if I put m, I will get e to the power minus sm over minus s, and minus e to the power 0 is 1 over minus s. So this is what I got. Now if you take the limit, this will give you minus minus plus 1 over s e s, and this is minus 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 1 over s, and plus, if you take the limit of this thing, it is 0 because limit of e minus sm goes to 0 as m goes to infinity. Okay, so I will get 0 here and plus 1 over s. So your answer is 1 over s e s. This is your answer because 1 over s minus 1 over s cancel. So this is your answer. Okay, so if I give you a function like that, then you have to use integration to find the Laplace inverse, Laplace transform. But if I ask you something from the formula table, let's say what is the Laplace transform of t square, I know that table gives me this formula, t to the power n is n factorial over sn plus 1. This is the formula from the table. So I can use with n is equal to 2, so this will become 2 factorial over s2n plus 1. So I just replace the value of 2, you see here, right? So this becomes 2 over S3. 2 over S3 will be your answer. So if I ask you that use tables to find Laplace transform, okay, then you can just use formula, then do this, okay. But if I ask you to use definition, because this function is not in the table, this function is not in the table, so if they ask you to find the Laplace transform of this one, we have to integrate, okay. So this table will be given, okay. So use tables, tables will be given in the exam. I will write these formulas in exam. So if the formulas are given in the exam, I do not think there is any difficulty left. Okay. Similarly, Laplace inverse transform as well. Let's say if table says that the Laplace inverse transform of k over s square plus k square is equal to sine kt, right? This is the table. But if I ask you what is the Laplace transform of 1 over s square plus 16, right? Then I have to rewrite this as Laplace inverse of 1 over s square plus 4 square is 16. But if there is this k, then k is at the top as well. So I need this 4 at the top here. So if you multiply this 4, I have to divide by 4 outside. Agree? So now outside 1 by 4 will remain there, and this thing will become sine 4t. So using the formula is also a trick. You cannot just, even if the formulas are given to you, right, this will be given to you, then you still should know how to use them. If you do not know how to use them, even the given formula will not help you. Okay. So one problem is that, and the second problem of from this chapter will be solve ODE or initial value problem. Solve an initial value problem using Laplace transform. Using Laplace transform. So basically, initial ODE plus an initial condition will be given to you. Okay. So one question like that. Okay. So let's say if I pick something from 7.2, which has uh, 7.2. At the end of 7.2, I think I have some questions. Uh, let's do something. Problem, I don't know which one was in the assignment. Let me check in the assignment. Assignment 3, 1, 7, 11, 15, 33 and 35. These two I gave you. So 30, I did these two equations in last lecture. In my last lecture, if you see, I did both the equations, I think both the questions, or 35 I did in the class. So let me pick something which is little more difficult. Maybe let's say 34. Y prime plus 6y is equal to e to the power 4t. Let's say this is your equation and y0 is equal to 2. So this is the initial value problem. How to use Laplace transform? We take the Laplace transform of each term. So this is the first step, just the equation, not this. Laplace transform of y prime is s Laplace of y minus y0, and this formula will again be given. Plus 6 Laplace of y as it is equal to 1 over s minus 4. This is the Laplace transform of, again this formula will be given. These tables will be given to you, okay? So don't worry about this. Now y0 is 2. You see, this is given 2. You see, y0 is given as 2. So you can combine these two, s plus 6 Laplace of y. This comes here and this comes here, and then you see Laplace y is common, so this minus 2 will go on the other side, so minus 2 over s minus 4. Okay, so this minus 2, you see this minus 2 went to the other side. So now I can uh, simplify, I can take the LCM, so it will become 2s minus 8 plus 1 divided by s minus 4. When you take LCM, you multiply it here. So 2s minus 8 plus 1 and divided by s minus 4. So 2s minus 7. This will become 2s minus 7 by s minus 4. Now if you divide by s plus 6, you get Laplace of y is equal to 2s minus 7 divided by s plus s minus 4 is there, and 1 s minus 6 will come from here. Okay, s plus 6 will come. Now I have to find the Laplace inverse transform. This is the last step. Y is Laplace inverse, therefore Laplace inverse of 2s minus 7 over s minus 4 s plus 6. This is what you have. But I will hold on. I cannot find. If you look in the table, Laplace inverse of only 1 over s minus a is given to me, which is e to the power at. This is only given in the table. So table gives you this only. Okay, so I do not have anything which is the product. So what I will do, I will use partial fractions to separate these two things. I will use partial fractions to separate these. So if I separate these two, uh, how to separate them? I will write, partial fraction says that write this expression 2s minus 7 over s minus 4 s plus 6. We separate these linear terms s minus 4 separately, s plus 6 separately. So we write a constant at the top, a constant at the top. Then 2s minus 7, the top one, here I multiply a with s plus 6 and b with s minus 4 with this one, okay, plus b with s minus 4. That's it. And now I will put two values, s equal to 4 and s is equal to 6. If I put s equal to 4, 4 to the 8 minus 7 is a into 4 plus 6 10 plus b gives you 0. So you got a is equal to 1 over 10. And from s is equal to minus 6 will give you minus 12 minus 7 is equal to 0, and b minus 6 minus 4 is minus 10. So I will get b from here, which is minus 19 by 10. Okay, so therefore what I got, this I will replace them here. So therefore 2s minus 7 over s minus 4 s plus 6 becomes a over s minus 4, which is 1 over 10 over s minus 4, plus b over 10, which is minus 19 by 10 over s plus 6. Now we can take the Laplace inverse transform because now they are separate. Okay, so now this 1 becomes, you see, now equation 1 will give you, therefore equation 1 gives you y, which is Laplace inverse of 2s minus 7 over s minus 4 s plus 6. This was my equation 1, but now I know that I can write this as 1 over 10 Laplace inverse of 1 over s minus 4 minus 19 by 10 Laplace inverse of 1 over s plus 6, because we have this expression, right? So if I write this thing as this plus this, if you want Laplace inverse here, this will give you Laplace inverse here, Laplace inverse here. Okay, so then I can write constants outside and write the formula. So now I have, from the formula I know that this is, this Laplace transform is e to the power 4t. What happened? No. Oh my god. Where has that gone? Is this all gone? What happened to that screen? Can you see that screen or it's gone? So what we had at the end, we got 1 by 10 e to the power plus 4t, because it was s minus 4 uh, s minus 4 was there, and minus 19 by 10 Laplace inverse of 1 over s plus 6. This is what I got. So 1 over 10, this becomes e to the power 4t from the tables, and 19 by 10, this is e to the power minus 6t from the table. So this is the final solution. Okay. So these are your all the questions. I will try. In 7.3, you only have, I gave you maybe a lot of questions from there as well for the assignment. But one thing which you should do is uh, the property that we use for translation on s-axis. I gave you some problems over there, but only thing is at the end when you take the Laplace inverse transform, just one property, extra property, we call it translation about s-axis. S-axis in the Laplace inverse. You know that Laplace of ft is fs, right? So he said if I translate s to s minus a, then what happens to my original function? Original function gets multiplied by e to the power at. So this translation only gives you this thing. Okay, or you can use this property in opposite side. Mostly this is the most applicable, that when you have Laplace transform of fs as f of t, if this is known to you, then the Laplace inverse of fs minus a, that if you have s minus a, then it becomes eatft. This is the extra factor for this one. So let's say if they give you Laplace inverse of 1 over s minus 1 square plus 1, right? This means that if you change this to Laplace inverse 1 over s square plus 1, let's say if you do that, so what you did, you removed this translation. If you remove this translation, it gives you e to the power at. So this property takes care of these things, these type of translation things. So e to the power at is there, and now we know that this answer is sine t. So directly I don't know, it looks like sine, but sine only has s square, not s minus 1 square. So this is the property which helps you find the Laplace inverse transform when you have a translation. Let's say Laplace inverse of 1 over s plus 1 to the power 3. I know that if there is no s plus 1, if it is just s to the power 3, if it is not s plus 1, just s to the power 3, then I have the Laplace inverse transform. But if I remove this translation, I need e to the power minus t, because a is minus 1 here. You see, I need s minus a. If s plus 1 is written, it means a is minus 1. So that I put here. Now I know that this is t square divided by 2 factorial. Okay, so I got t square e to the power minus t divided by 2. That's my answer. So I may ask you one question where you have to use this property. Okay, this will be the part of question 1, where I will ask you Laplace transforms and inverse Laplace transform. In question 1, from 7.1, one question, I will ask you Laplace and inverse Laplace using the tables. Okay, so here you may need this property as well. Okay, so 7.3 will only include here. Okay, 7.1, 7.2, where I have to ask you only the transform. So the one question like solving differential equation. Okay, solving initial value problem, which I just finished at the top. All right, guys. So this is all about the review session. I will see if I can get that file back, which just got closed automatically. If not, then you have to see the video and note down the questions. Then I will have no solution for that. Anyway, that's it from my side. If you have any questions, let me know.